Good evening, students. Good evening. Good evening. Am I audible? Yeah. Very good evening. Very good evening. Ganeshwar Sai material cannot be given in PDF. Otherwise, so nobody will buy na hard copy. Not possible. Nobody will give you. Okay, you have to wait maybe whenever they are saying NSR, sir. Okay, yes. Good evening. Good evening, Shania. Good evening. ठीक है. Good evening, Naveed. Uh, the syllabus has been shared, I think, na? Yes, good evening, Swati. Good evening to all. I hope you people are preparing well for the test. Good evening, Manish. Good evening, Gayatri. है ना? So test syllabus is updated. Yes, Farida, good evening. Swati, yes. Blessy, good evening. Ganeshwar Sai, I told na, you have to only wait as if NSR sir is saying that it is yet to be printed, or he is saying another lot will come. Till that time you can wait because PDF cannot be shared. Yes, Arshad, good evening. Vishwanath Reddy. So how's the preparation going on for the test? Test syllabus is already, I think it was covered in the previous lecture. है ना? MOT is not there in the test syllabus. So firstly, you want to ask any questions up to the test syllabus. Any questions you want to ask up to test syllabus? Then we will continue with the MOT. So any questions you want to ask up to test syllabus? नहीं, अरे are you solving? Sajid, are you solving the questions? NCRT exemplar, NCRT line by line reading, are you doing it? It's very important, make this habit. Resonance we have done. Then I hope you have read this part where it is one paragraph given. This portion. Bond parameters पे NCERT is giving you precisely very small things, very small paragraphs are given. Like what is given, bond length definition given. Then what is mentioned here, bond lengths are measured by which ways? They are measured by the spectroscopic techniques. Only to know the information you can mark them. Like here given by spectroscopic techniques, or by these techniques we can find. So I hope you are going through these parts of the NCERT as well. Then covalent radius, van der Waals radius you have done in the periodic table chapter. Yes, maximum is van der Waals, then metallic, then covalent. That is the part here. Then on next page it is given, bond angles are given, bond angle terms. Bond angle is expressed in degree, which can be experimentally determined the spectroscopic methods. Yes. Then here example they give H2O. Bond types are given. Bond types means OH bond, CH bond. Out of OH bond and CH bond, which bond length is more given? We cannot learn the bond length, understand, है ना? Some questions we have done na, bond length, bond angle, HF, HCl, like that. Here OH bond given what? 96, CH given 107. You know that more is the EN difference. stronger will be the bond. So here stronger bond means shorter bond length. Remember this part, that bond length and bond energy generally inversely proportional. Exception we have done in F2Cl2Br2. I hope you remember that. Same way, we can generalize these terms. Okay, we can generalize them. We cannot learn the values. Like CO bond and CN bond, equal values given. So that we can, okay, fine, questions cannot be framed on that directly, but where some significant difference is there, we can frame the questions. Like here, which is useful, C triple bond C, C double bond C. Which bond is stronger? C triple bond C or C double bond C? Which is stronger bond? Which is stronger bond? Triple bond C or double bond C or single bond C? Triple bond, double bond, or C single bond C? Okay, 2 students responded. Okay. Okay, fine. Okay, there is no doubt about that. I thought someone will say C single bond C, then good. So stronger bond, that is why bond length is less as compared to C double bond C. Then C single bond C. Already we have done this example where in same type of questions, bond length, bond parameter, in bond order I have given that example. Then you can observe C double bond O and double bond O. Out of these two, EN difference where more? Between CO bond, double bond O and double bond O, where EN difference more? Where EN difference more? Electronegativity difference more. Very good. C and O as compared to NO. So on that basis, we can get general idea. We cannot learn the values. Again, I am saying. The more EN difference, then it will be a stronger bond, so shorter. How much shorter? We just can say by the values given. Then you can observe C double bond N and C triple bond N. Same like C double bond C and C triple bond C. Out of these two, C double bond N and C triple bond N and C, these two. Out of these two, both are triple bond. Why C triple bond N is shorter given? Can you compare? On which basis we can say this is a shorter bond? Anyone? Yeah, EN differences where more in CN. More EN difference, you can say more strength of the bond, hence shorter bond. So when you go through it, you can go through these general examples given. ठीक, उसके बाद that if you this one is again bond length given, but remember one thing, among the atoms same type na, homoatomic we can say, same type atoms, single bond, which is highest bond energy? Yeah, Seni, you should read. You will not stop. You will only do what? Today's part you will read first, then you can practice for the test syllabus. Okay? Students, I am saying that HH bond, FF bond, Cl single bond. If the question I am asking among these, okay, all single bonds, can you comment on which has the highest bond energy among these? Among them, which has the highest bond energy? Yes, Syam correct. Delhi Ames correct. Yes, correct. So here HH is, if you remember, or else in hydrogen chapter when you read some properties of hydrogen, there it is given that HH bond energy is highest, single bond. Single bond, highest bond energy is for which atom? Hydrogen. Not CC, not OO, not NN, not II, not CL. Okay, why? Because 1s orbital. Electrons are closest and then a best overlap takes place. So by the value you can say no doubt. But just I said this one, when you read the hydrogen chapter, this is given there that HH bond energy is highest. One of the single bond, highest bond energy value is for HH. Not CC, not OO, not FF. Okay, that example we have done. Bond length F2Cl2 Br2 I2. What's the bond length order? I2 maximum, then Br2, then Cl2, then F2. Normal trend. But bond energy trend is Cl2, Br2, F2, I2. आया याद कुछ? So here they have given bond length trend that you all easily can guess, but bond energy here going slight variation. That reason is lone pair repulsions in fluorine more. Then this is normal double bond and triple bond, which is more bond energy, NN triple bond length is given more for O2. This already we have done in VBT example also. Okay? So, but still I am just thinking that you should read the part completely. You can read all the story which is given here. Okay, resonance completed. So, shall I continue with MOT or any point, any question you want to ask in any paragraph? Bolo. Any point, any question you want to ask from the paragraph, or else I can continue with the molecular orbital theory. Dipole moment, yes, later on. Dipole moment later on. Topic which are not covered yet, that will be after MOT. Which are not covered by this time, H bonding and this, that, they will be after bonding. After, sorry, MOT. ठीक है, चलो start करें. So in the last lecture we have completed up to which part? Till which part it was done? Okay, till linear combination of atomic orbitals. We have written the points that, ठीक है, conditions also started. Okay, so in the last lecture we have discussed that part. ठीक, that MOT diagram you can understand here first, then we will draw in the electronic configuration. These are the atomic orbitals. Combining, what is generated? One bonding, one anti-bonding. Acha, if you observe here, yeah, Vijay, it's not there. In this test, it is not there, but it is there in the coming test also. So we cannot stop here. Okay, one question I am going to ask. ठीक है, अब देखो. Are you able to observe here? Are you able to observe here? Suppose this is del x, it is del y. Oh yeah, ye. Can you comment on these two? Is del x equal to del y or not? Is first option del x is equal to del y, del x is greater than del y, del x is less than del y. ठीक है. Okay, that means the energy raised for anti-bonding is more as compared to it is decrease for bonding. Yes? Anyone can explain? Yes, very good. Shyam correctly said. Srinivas, can you explain? The change in energy is more for x greater than y. Okay, Sajid, x greater than y. Very good. X more than y. Fine. Can anybody tell? Yes, Shyam. Very good. Actually, what happened? Theoretically, if you say theoretically, yeah, theoretically, whatever energy change is there, it remains equal. It is given where? It is. ठीक है. The point is, generally, theoretically we say BMO decrease, parallelly ABMO increases. ठीक है, theoretically equal, but experimentally observed that the change in energy for ABMO is more as compared to change for bonding molecular orbital, or the delta X is not equal to delta Y. Experimentally, theoretically they both should be equal. Whatever decrease exactly equal to increase theoretically. Practically, in the diagram of NCERT, we can observe they have maintained the gap. They are not explaining it, but they have maintained the gap. Like ABMO has more increase in energy because experimentally observed the degree, the repulsion factor is very high, or repulsion factor is more higher, that leads to more increase in the diagram. ठीक है? Getting it? So here it is given total energy of the two molecular orbitals, however, remains the same as that of the two original atomic orbitals. That is, though atomic orbitals, the value remains same overall, but where gap is more, ABMO more and BMO less, because repulsion factor between the electronic repulsions and internuclear repulsions, that factor is experimentally final output that it has more dominated. So delta X is actually greater than delta Y. It is not delta X equal to del Y. Okay, going back to the conditions. Conditions we have done. What are the three conditions? First condition, whatever combining orbitals are there, they should have proper symmetry or same symmetry. ठीक है. Example written, 1s with 1s, 2s with 2s, but 1s can never overlap with, same symmetry. Same symmetry means that they have px with px, py with py, or pz with pz. ठीक. Second, they should have proper similar energies. The combining atomic orbitals should have similar energies, which means that 1s orbital plus 1s orbital. 1s with 2s will not accept that one. And third point is the atomic orbitals should combine or should overlap to the maximum extent, so that what happens, stronger bonds are formed. What will be formed? Stronger bonds are formed. Then types of molecular orbitals we have to start today. In the types of molecular orbitals, underline these three. Underline these three. So here clearly given but not explained delta. What is given? Sigma and pi. We always talk about these two because in MOT we have up to 20 electron system, and that is, if you remember, it is up to pi star 2px, pi star 2py. ठीक है, delta but given here, so just remember that, but its usage is nowhere given because delta bonds are formed by the d orbitals. They are involved, or they are formed by which orbitals? D orbitals. But for NEET level it is nowhere mentioned in NCERT, so even if you read it, it's extra information. Clear? Now next part is the types of molecular orbitals, and what is given there? Molecular orbitals में sigma and pi, and then this, that is given. ठीक है, तो firstly types of molecular orbitals में first is which one? Sigma molecular orbitals. First कौन से हैं? Sigma molecular orbitals. How these are formed? These are formed when overlap takes place along the internuclear axis. So write down that term. They are formed they are formed when overlap takes place along the internuclear axis. Overlap along the internuclear axis. ठीक है? Generally, which axis is taken as internuclear axis? Generally, which is considered as internuclear axis? Good, very good. Sajid, Syam, good. Manish, Vijay, very good. Kavita, yes, good, 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 very good. It is clearly given. By default we take Z. If change is there, that should be mentioned, then that will be taken. Clear? So here overlap along the internuclear axis. Then what are the possible orbitals here? Up to 20 electron system which are used. 1s orbital, then 2s orbital. S orbital will form which bond? Sigma bond only. Yes or no? We have done in VBT. S orbital, sigma bond. S orbital with P also sigma bond. S orbital will only form sigma. ठीक है? But in P there are three possibilities: Px, Py, Pz. So among them, Z is the internuclear axis. So Pz will form which one? Sigma bond. And Px, Py will be pi bond. Where we have done that type? In VBT also discussed. Yes. So that point using here, 1s, 2s, and which 2p? 2pz. They will form which one? They will form sigma molecular orbitals. When 1s combine, 1s orbitals, they result into which one? Sigma 1s and sigma star 1s. Same way, sigma 2s, sigma star 2s. 2pz में sigma 2pz, sigma star 2pz. ठीक है? Sigma 1s means which bond, which orbital? Bonding molecular orbital. Sigma star means anti-bonding. S orbital means sigma bond form. Now in MOT, one will be bonding, other will be anti-bonding. When two s orbitals combine, then one sigma, other sigma star. When 2pz combine, one will be sigma, other will be sigma star 2pz. This is for sigma molecular orbitals. Same way you can write for pi. You can write for pi molecular orbitals, which will be there 2px and 2py. Write down these, then we will talk about pi. That results into pi bonds, pi orbitals, pi star and normal pi 2px, pi star 2px. Other one pi 2py, pi star 2py. This is bonding, it is anti-bonding molecular orbital. Bonding molecular orbital and pi star anti-bonding molecular orbital. Done. Now after this type, then MO diagrams are given there. This one. Okay? Now they are very important. They are very important. This is firstly which overlap? Same sign, positive overlap, plus given, addition. Whenever addition takes place, if you remember last class we have done, psi BMO is psi A plus psi B. Psi ABMO is psi A minus psi B. So this is which one? Bonding. Okay? This is which one? It is bonding molecular orbital sigma 1s. Here there is no nodal plane. Where in sigma 1s you can say or sigma 2s, both same, only size will differ. So remember last time you have written what? That the bonding molecular orbital psi BMO may contain nodal plane, may not contain nodal plane. So in sigma 1s, that is bonding molecular orbital, there is no nodal plane. What is the meaning of node? Where the probability of finding the electron is 0, and that plane is termed as nodal plane. So here there is no nodal plane. Clear? Yes. It is for bonding. What about anti-bonding? See here, minus given. This is minus means psi A minus psi B. That results into anti-bonding, and that point what is written in psi ABMO? They always contain what? They always contains nodal plane. Now check it. This is subtraction. So what will happen? Due to anti-bonding, there is a less electron density in between the two nuclei. You can see here, these two nuclei here, electron density is reduced. Electron density is reduced. And between them, what is there? This is nodal plane. Clear? The anti-bonding always contain nodal plane. Bonding molecular orbital, they may contain, they may not contain. आई बात समझ में? Important diagrams question can be framed easily on that. है ना? Diagrams can be given, among them which is correct for sigma star 1s, among them which is correct for this one about nodal plane. Then check for 2pz. In 2pz we know there will be sigma. In 2pz there will be sigma. So here firstly, which one? Addition. Addition means bonding molecular orbital. This is bonding molecular orbital in this manner. That here electron density is increased between the nuclei. Electron density increased here. So you can say electron density increased here, that is giving more attraction. Here between the nuclei there is no nodal plane. Between the nuclei there is no nodal plane. Getting it? Where it is there? In the original 2pz, because 2p means this one now. Initially they have that one. Here also initially they have that one. Plus, plus, minus, minus. So that is the diagram for sigma 2pz. Now what will happen? If it is anti-bonding formation, this one, minus, then what will happen? Again, electron density will be reduced between the nucleus. And what happens? This type of diagram is given. Here also this type. Electron density reduced. Here it is, suppose it is plus, it is minus sign, it is plus sign of the wave function, and that is given. Getting it? This is clear. Between the nucleus, what will be there? Nodal plane. In anti-bonding molecular orbital. अरे भाई आ रहा है समझ में? These diagrams are important. Because of the repulsion, the electron density is moving away from the nucleus is in between. They are moving away from that. You can see here. It is shifted on the opposite side. It is shifted upon the opposite side. ठीक है? Okay, good. Then next one. Next one here. Firstly, 2px, 2py, same na? Pi, pi. 2px, 2px, pi, sigma, pi, bonding molecular orbital, or 2py, 2py, also it will be bonding molecular orbital. So here same sign overlap. Plus, plus, minus, minus. That is the shape if you remember. Maybe by looking at that you might be confused. That is the shape. What will happen? Same sign overlap, bonding molecular orbital. So in this case, it is which one? Pi bond, and pi bond density is per above the plane and below the plane. ठीक है? That is the pi bond. मतलब bonding molecular orbital for which one? Pi 2px, pi 2px or pi 2py same. It is for bonding. ठीक? Then anti-bonding. Anti-bonding with plus with minus finally. So what will happen here? In this case, electron density repelled. Repelled backside. Getting it? Here also electron density repelled. See that one. Repelled, electron density on the behind it, and here it is given these are the nodal planes in pi star 2px or pi star 2py. Yes, two nodal planes are there. ठीक है? Getting this idea? This is sigma 1s. Yes, electron density increase there. If it is given opposite sign which is given there, this results into anti-bonding. And firstly I draw the This is sigma star 1s. This is for which orbital overlap? It is for first 1s orbital. That gives only sigma. One is sigma 1s, other is sigma star 1s. Here one nodal plane is there. You can say plus plus here, sign also you can mention as per NCERT. Only thing is I am here mentioning plus minus to mention. Another sigma is 2pz. Plus minus here, plus minus. You can say like this also as per NCERT also, they are only writing plus minus in between. Both are correct ways. That way also you can say. So here it is bonding molecular orbital. This is sigma 2pz. Then plus here minus there plus. That is one way. Or else keep that as it is in between minus sign. So it results into anti-bonding, electron density reduced, and hence one nodal plane is there. Here it is minus, it is plus, it is minus, it is plus, and that is the sigma star 2pz. You can write this manner also, or you can say same plus minus, here minus, plus minus. Okay, depending on the option, you have to be alert that that is also possible. It is given in NCERT. It is also correct. So these are which one diagrams for bonding, anti-bonding in case of sigma. Okay, then for pi. For pi, the possibility is plus minus here. Summation it is. This may be what? It may be 2px, or it may be which one? Or 2py, and that is the internuclear axis. So it results into above the plane and below the plane, plus minus. This is pi 2px, that is bonding, or pi star 2py. Both are pi star near. Any of them will be same. Clear this one? It is for pi, same sign overlap, psi a plus psi b you can say, and it is bonding molecular orbital. You can observe here nodal plane has to be there. So bonding may contain nodal plane, may not contain. So 1s and 2s, they have no nodal plane in their bonding molecular orbital, but in pi that is surely there. That is the internuclear axis. Other one is plus minus plus. That is the way, or I can write both same sign between minus. That is also giving you same answer. Or I can draw it like this also, which is generally given. Firstly, drawing the nodal planes. Okay, it is repulsion factor is there, they are moving away. And here plus, it is minus, here minus, it is plus. This is anti-bonding. Pi star 2px, or same for pi star 2py. How many nodal planes are there? 2 nodal planes are there. That is clear? Done. So that diagrams are useful for the question format, can be easily framed among the following, which is correct about pi star 2px, which is correct about sigma 1s, which is correct about sigma star 1s. They all are relevant. So you have to understand those. These are the only few diagrams which are relevant. Remaining, if you get in the any books for information, you can read if you want, but that is not important. It is up to only pi star 2px and pi star 2py we are going to discuss. Now next part is what? Next part, I think it is your favorite part for MOT, which is the writing the configuration. That is this one. This part where actually we talk about the energy level diagram for molecular orbitals, and here it is the configuration used, bonding, anti-bonding. Here what is given? The energy level of these molecular orbitals have been determined experimentally by spectroscopic data. For which one given in NCERT? Homonuclear diatomic molecules. We are discussing the electronic configuration of homonuclear diatomic molecules. Using them, we can find for some heteroatomic also. Remember O2 there, we can write the configuration. CO given, we do not write the configuration, we treat like homoatomic only. But the electronic configuration for MOT is given for only homonuclear diatomic. Okay? Then increasing order, firstly for given for which one? O2 and F2. That is given, then the sequence changes for up to nitrogen. That sequence changes because of some 2s and 2p orbital mixing. Which mixing is there? Some interactions are there between 2s and 2p orbitals. Because of that, slight variation in the energy, like where it is change only. Here only it will change. Sigma 2pz less than pi 2px, pi 2py. It is for O2 and after that. Slight variation here. Where it is there, it is here. Pi 2px, pi 2py, and then comes sigma 2pz. Only that is the variation. Where in writing the electronic configuration up to 20 electron system, till n to one set of configuration, after n to another set of configuration. Okay? So now we'll start or talking about the electronic configuration which is given. It is for which one? For homonuclear diatomic molecules. Having more than how many electrons? 14 electrons. Having more than 14 electrons, like O2, F2, etc. Or we can say after 14 electron system which comes O2 and its ions, that will be applicable. What is the increasing order? Increasing order will be sigma 1s, sigma star 1s. 1s orbital bonding, anti-bonding. Then sigma 2s, sigma star 2s. In 2s orbital, how many? One bonding, one anti-bonding. Now in 2p, sigma 2pz. Sigma will be always less. Generally, whenever interactions are there, slight variations will arise. Then pi 2px equal to pi 2py. sigma 2pz, then pi 2px equal to pi 2py. After that, then comes pi star 2px equal to pi star 2py, and last will be sigma star 2pz. This is the electronic configuration up to where we are discussing for sigma star 2pz for oxygen beyond 14 electron system, pi star 2px, pi star 2py, and last is sigma star 2pz. It is for O2, O2 ions, O2 plus, O2 minus, O2 minus 2, F2 like this, or up to 20. Ne2 also we will follow that one. ठीक है. Second case will be up to less than equal to 14 electron system. That is Li2, B2, C2, N2 and its ions. ठीक है, like which one? Up to nitrogen or ions of nitrogen, that will be also follow this configuration. ठीक. That will also follow this thing. So let's see, will it work or not? ठीक है. That is the configuration for which one? Up to nitrogen. ठीक है, it is for up to nitrogen. That variation is here. That variation is here. Getting it? The variation is where? Up to nitrogen, due to more interaction between the 2s and 2p orbital. That gap decreases, and what happened due to those interactions or due to those mixing concept, the sigma 2pz becomes more in energy as compared to pi 2px, pi 2py. Although it is clearly mentioned in NCERT, it is purely by the spectroscopic data. This is experimentally getting, but reasoning can be due to the more interactions up to nitrogen between 2s and 2p orbital, then sigma value is slightly more than pi 2px, pi 2py. Other portion as it is, no change. Pi star 2px as it is, pi star 2py, sigma star 2p, z also as it is, no change. So these two configurations we are going to follow. ठीक है? Clear up to this point? So we are going to follow these two configurations. It is quite easy, and good easy questions generally came from MOT by using these configurations. So shall I continue with the writing the configuration today, or in the next class we will do for all the elements Li2 to Ne2, or you can practice some of them if you have time, maybe you get the time, so you can try. Then we will talk about bond order in this concept. Tell me, because next will be the individual molecules Li2, C2, B2, BE2, HE2. These has to be written. Tell fast. In next class, can we start with the new part? In the test syllabus, MOT is not there, so maybe we can practice the exact examples. Today, theoretical part we have done. Next class will be for writing the configuration and then bond order. Ganeshwar Sai, the reason more important is in NCERT it is given through spectroscopic data. So that I will say more stress. Other reason maybe next class I will again start from this part. Okay? Okay? In next class I will start from this. Reasoning part I will say that what is given in NCERT, that is spectroscopic data decides the order. Okay? Then we will talk about the configuration, bond order, stability part. Okay, students, so MOT we can do up to here. You can try your best in that test. Then we will discuss the questions also of the test. If you have doubts, you can ask. And then we will complete the MOT, most probably in the next class. ठीक है, चलो. All the best for your test. Let's see who is the topper, offline student or online student. Who will be the topper, I think. Offline students are getting the marks. What do you say? Sajid, what's your viewpoint? Gaming. Questions, Jim, how would I post here? Module is not there. Okay, let's see who is going to get the maximum marks. Who is the highest scorer here, offline or online? Let's see. Okay, take it as a challenge. You are the people who are getting the all resources at home, है ना? So best way we can see how you are utilizing it. Let's see this test. Chalo. Okay, bye.